Polynomial functions, leading coefficient. So determine the behavior of the functions by applying the leading coefficient test. Let's say we have here the function a. A f of x is equal to minus 3x cubic plus 6x minus 13. And we want to know the end behavior of the function. So a, the leading coefficient, is less than 0. And we are looking here for the degree. What is the degree? The degree is 3, so it's odd. Because the degree is odd, we can write this way. And we can see for the test what it says, the test. For the degree n is odd, you see here is the function. If the degree n is odd and leading coefficient an greater than 0, we have for the left side false and the right side rises right. But our case is this case here. An is smaller than 0. It means in the left side rises in the left side and then behaviors false on the right side. So we have this scenario here. On the left side rises and on the left side, and on the right side it falls down. So as the x approaches to negative infinity, to the left to negative infinity, f of x approaches positive infinity because it goes up, approaches positive infinity. And to the right side, as the x approaches a positive infinity, then f of x, let me write f of x, approaches negative infinity. And for the b is leading coefficient a is greater than 0. But the n, the degree n, is even. So it's even. And it's a positive. And we are looking here for the leading coefficient test. If a degree n is even and leading coefficient greater than 0, right in the left and the right side, the end points rises. So what does it mean? It means here goes this way. Left side goes up and right side goes up, the end behaviors. So as the x approaches negative infinity, f of x approaches positive infinity, goes up. If it goes up, approaches positive infinity. If it goes down, negative infinity. And now, as the x approaches to the right, to the positive infinity, f of x approaches positive infinity, goes up. Whenever goes up is a positive infinity with respect to f of x. And now we're looking at this case. In this case, a, leading coefficient a, is less than 0. But the degree here, n, is even. So the degree is even. And we are going to look here in the leading coefficient test. If n is even in degree, and an is a leading coefficient greater than 0, it means both of them are going up. But we have the opposite. We have an is smaller, is less than 0. If leading coefficient is negative, it means both the endpoints in the both sides, they fall to the left and to the right. What does it mean? This is going to be this way, to the left and to the right. So as the x approaches to negative infinity, f of x to the left means approaches down, so is a negative infinity. F of x approaches to negative infinity. And the same way to the right, as the x approaches to positive infinity, f of x approaches negative infinity. And now we have the last scenario. Here is a leading coefficient a is a greater than 0. And the degree n is odd. So degree n is odd. And now let's see here in scenario when we have odd. N is, let me see it. An is greater than 0. So we have this case. So in the left side, it falls, the endpoint. In the right side, it rises. So it means we have a fall here, to the left and to the right rises. So as the x to the left approaches to negative infinity, f of x approaches to negative infinity. And to the right, as the x approaches to positive infinity, excuse me, f of x approaches to positive infinity. And this is take care of all the examples here.